In this section we will discuss about functions and what is the meaning of function, and we have already learned about relations. What is the meaning of relation? That is any subset of a cross A is known as a relation, and here we will discuss about functions. What is the meaning of a function? It is given like this: a function is a special case of relation. Here it is given that a function is a special case of a relation, and uh, that is a relation which satisfies some conditions, which is known as a function. Which are those conditions? Here definition is given like this: if x comma y are two non-empty sets, then a subset of x cross y is called a function or mapping or map from x to y if and only if for each x comma x belongs to capital X, there exists a unique y belongs to y such that x comma y belongs to f, and it is written as f is from x to y. That is otherwise the conditions, we can also say that thus a subset of x cross y is called a function from x to y if and only if for each x belongs to x, there exists a y belongs to y such that x comma y belongs to f, and no two different ordered pairs have same first component. And here we are writing each elements as an ordered pair. So we can consider, we can explain this one by using an example. Suppose by using arrow diagram we can see this. Suppose this is set A and this is set B, and suppose there is a function f like this, and here elements are 1 2 3, and here elements are 4 5 6. Any element we can take. The condition is for all elements of A must have a unique image in B. That means here image of 1 if you are taking as 4, 2 if you are taking as 5, 3 also if you are taking as 5, then can you consider this as a relation? All the elements here set A, 3 elements are there, 1 2 3. We can see that all the elements have unique image, no? And if you consider any element in the set A, only a unique image is there, no element has more than one image. Suppose if you are considering another relation like this, suppose this is a relation from A to B, and here elements are 1 2 3, and here 4 5 6. Suppose 1 is related to 4 and 1 is related to 5 and 2 is related to 5 and 3 is related to 6. So here we can see that all the elements have all the elements have their own images in B. But when we check this one, here one has two images in B. So we can say that one has more than one image. So here the image of 1, it is not unique, so this relation we cannot consider as a function. I think you all have understood this one. So the condition is for each x belongs to x, there exists y belongs to y such that x comma y belongs to f. That is, for all elements in the first set must have an image in y, and next to one, no two different ordered pairs have same first component. That means they should not, that is, all the elements of x must have a unique image. That unique is very important. More than one images, that is not possible. Only one image it is possible there. For explanation we can consider this function as a machine. What is the thing happening in a machine? That is, we are inputting something into the machine. After some functions we are getting some output. So if you input the raw material, we are getting some output. So when we input something, we will not get different types of output from the same machine, a machine which provides same kind of outputs. That is the same thing here. That is a function f can be thought of as a mechanism or device which gives a unique output f of x to every input x. If you input something into a machine, it will give a unique output. It will not give different outputs because a machine which is function for a unique output. And next thing, it is image of an element. The unique element y belongs to capital Y is called the image of the element x of capital X under the function f is from x to y, and it is denoted by f of x. So that is suppose when we consider the first set and after its images, we can see in the second set, if the function is defined like this, if it is defined like this, a function is from x to y. Here the first set is capital X and second set is capital Y. Suppose the elements of x must have some images in y, and here the elements of capital X, if we are considering as small x, its image in capital Y we are considering as y, small y or f of x. That means the image of x can return as f of x or small y. Next thing, that is domain and a range of a function. What is the meaning of domain and range of a function? Here domain means, that is, here we have already said a function, we can write as a function is from x to y. Here capital X is the first set and capital Y is the second set. It is defined from x to y. So all the elements of this capital X, if you consider this example, here set 1 2 3 is known as domain, and B we can see 3 elements, that is 4 5 6. The set 4 5 6 we can consider as codomain. Then what is the meaning of range? That is the collection of all images. Look at the example here. Only 4 and 5 have some pre-images in A. Otherwise 1 2, when we consider these 3 elements 1 2 3, when we consider the collection of images of this 1 2 3, we will get set 4 and 5. So here we can say the range of this function, that is r of f, is equal to 4 5. Codomain and range both are different. Codomain means the set B itself is known as codomain, but range is the collection of all images. So here main features of functions are given there. Let f be a function from x to y. Then first one, to every x belongs to x, there exists a unique element y belongs to y such that y is equal to f of x. That is the basic definition of a function. And second one, no element of x can have more than one images in y. That is also we can see in the condition, because two conditions are there. This is the second condition. If you consider any element in x and which should have a unique image in y. And third one, there may be elements of y which are not associated with any element of x. I think it is, there may be elements of y which are not associated with any element of x. And we have already discussed one example, that is here the first example. Here set A we can see 1 2 3 and set B we can see 4 5 6, but here when you check this 6, it has no pre-image. So if it is a function, it doesn't mean that all the elements of B must have a pre-image. It is not the condition. There, if there is one element which has no pre-image, then also we can consider it as a relation. The condition is all the elements of X, otherwise all the elements of first set must have a unique image in the second set. And next thing, distinct elements of X may have same image in Y. That means in the same example we can see here the images of 2 and 3, that is 5. That means two different images of the first set can have the same image in second set. And fifth one, a function f is determined when f of x is known for all x belongs to x. If it is not, then only we can say that is a function. The next thing, it is real valued functions. Its definition is like this: let R be the set of all real numbers and x comma y be two non-empty subsets of R, then the rule or correspondence f which associates to each x belongs to capital X a unique element y of capital Y is called a real valued function of the real variable, or simply real function, and we write it as a function from x to y. Here the function is defined like this: f is from capital X to y. Here small capital X and capital Y are subsets of real numbers. So it is the same concept is same, there is nothing special, and here we are saying these things on the basis of real numbers. Suppose the function is defined from some real numbers to real numbers, otherwise some subsets of real numbers to some subsets of real numbers, then we can consider those functions as real valued function. The concept of function is same, but the set is the set of all real numbers or some subsets of real numbers, then we can consider it as a function. And when we consider its domain and range, then the condition is given there: the domain of f is equal to the set of all x such that x belongs to R, f of x belongs to R. The domain of f, we can say that it is the collection of all x in which f of x should be belongs to R. That is, if we are getting its image as a real number, then only we can consider that x as an element in the domain. Understood that one? That is, so when we are taking one element in the first set, then here the condition is its image should be a real number, otherwise we cannot consider that x belongs to the domain of f. Then what is the definition of the range? The set of images f of x for all x belongs to domain of f is called range of f. It is usually denoted by Rf. Thus Rf is equal to the collection of all f of x for all x belongs to domain of f. Domain of f means domain of f, we can domain of f means there is a collection of all x, and for all x we will get some images in the second set, that is the collection of all f of x, and those f of x, that is the collection of all images of all elements in the domain of f, is known as range of f. And afterwards some inequalities are given there. You already learned these conditions in your 11th class. We just go through this one.